All right, so next topic is phase diagrams. And what we're trying to answer here is under what conditions is something going to be a gas, liquid, solid, whatever. And so as we talked about previously, this is going to depend on two things. And those two things are pressure and temperature. Right, pressure and temperature. So on this y-axis, we'll put pressure. On this x-axis, we will put temperature. And so generally these go into little lines, something like this. And so each one of these regions is one of the phases. So at high pressures, right, where P is high and temperature is low, you can think about what phase would be favored there. You're squishing things close together. Generally, solids will be favored there. Over here in this region where we have kind of high temperatures and low pressures, we have a lot of energy and not a lot of things squeezing together. We're going to be a gas. And in between the two, we are going to be a liquid. This point right here, this intersection of these three phases is called the triple point. And this is where a gas, solid, and liquid coexist. So you have all three phases at once. Last point over here, this is called the critical point. Above this temperature, we have what's known as a supercritical fluid. And so above these temperatures, basically we can't distinguish between a gas and a liquid. Our supercritical fluid is something that has properties in between that of a gas and a liquid. It has the density of approximately a liquid, but it behaves by taking the volume such as a gas does. So it's in between a gas and a liquid. And so you can think about, at constant pressures, if we were down here going from the left to the right, we would go from a solid to a gas, so that would be sublimation. If we increase the pressure, we would go from a solid to a liquid, that'd be melting. And you can play around with different starting and ending points. So this stuff shows, these two diagrams basically show you the same thing, right? Solid, liquid, gases, the different phase transitions. This is, the one on the left is common for most molecules or most compounds. The one on the right is actually for water. And so there's a subtle difference, but it's pretty cool. You don't actually have to really know this. It's not that important. But you notice here, the slope is actually positive, whereas this slope is actually negative, right? So here, when we increase pressure, we're more likely to become a solid because generally solids use up less room than liquids. Whereas here in water, when we increase pressure, down here would be a solid, but up here at the same temperature, we would be a water. Think about why that is. The answer to that question is that water is a weird solid in that its solid phase is actually less dense than its liquid phase, right? Ice floats in water. That is very unusual. Most compounds are the opposite. So just cool little subtle difference between compounds that you might expect their properties and something like water, which shows some kind of abnormalities in it.